The human mind is an extremely powerful and mysterious thing, capable of things we may never understand. That right there is a concept, a multifaceted idea constructed out of information stored in various places throughout the brain, compiled differently for each individual, dependent on their experiences and recall capability. In his book, Phantoms in the Brain, Dr. V.S. Ramachandran discusses the issues of cognitive dissonance that can happen between perception and conception using the case study of a guy named Josh. Josh had accidentally taken a steel rod to the brain. It punched a hole in his primary visual cortex in the right occipital pole, the damage of which caused him to develop a scotoma, a blind spot in his field of vision several inches in diameter. A scotoma can also be a manifestation of damage incurred by any part of our visual system, from retinal damage to molecular degeneration. But nearly all mammals have a natural occurring scotoma, a location with no photoreceptor cells where the retinal ganglion cell axons that compose the optic nerve leave the retina. But our brains fill in the gaps in direct sensory intake with pre-stored knowledge relying on spatial conceptualization. We accommodate for the holes in the information through complex interplay between the occipital, temporal, parietal, and frontal lobes, which allow for filling in of information. The system of substitution is what Dr. Ramachandran began exploring with Josh. Although he lacked the ability to receive stimuli visually, Dr. Ramachandran found that Josh's mind would fill in the missing information through other channels in the visual cortex. But there were limitations. There was a lag in the filling, a few seconds generally, and Josh's mind was only able to accurately fill in patterns such as wallpaper or other series of repeating things, thanks to the parietal lobe's powers of continuity. But larger, non-repeating objects, which are processed in the temporal lobe, evaded Josh. He described the filling in he experienced as looking at hieroglyphics, the closest translatory approximation that his brain could make by merging the incomplete stimuli into the massive web of information he already possessed. The question Dr. Ramachandran asked is, does filling in occur separately in each of these areas, or does it occur all at once in just a single area? Through the case study of Josh, he answered his own question, which I further corroborated with the latest and greatest studies that the National Institute of Health has to offer. Filling in is done by a myriad of areas in the brain and can be divided into conceptual filling in and perceptual filling in. Perceptual filling in is enacted through the visual neurons that send highly specified irreversible messages to the integrated via the occipital lobes that are, for all intents and purposes, frozen as they're received. Conceptual filling in is a whole different ballgame, one played largely in the imagination. Our minds hunt for semantics to attach fresh stimuli to in order to determine its significance on a whole lot of levels. Is it safe? Is it pleasant or unpleasant? Is it valuable, necessary, inconsequential? We extrapolate as much as we can about the new fragments of information from what we've already experienced. This conceptual filling in is fluid, capable of changing with contextual changes, morphing as we learn and grow, and becoming part of the web of experiential knowledge, capable of informing future waves of stimulation. As for Josh, he could shift his gaze, and the unknown hieroglyphics became letters and numbers, as the functional parts of his visual cortex offered his brain what the temporal lobes could not completely fill in. But it is amazing the amount of information we are constantly compiling quite accurately in order to safely navigate a massively complex, ever-changing world. I have what is known as long COVID or post-COVID due to neurological damage caused by pre-vax classic COVID. Periodically throughout each day, I lose sight and motor function in my legs. This usually only lasts a minute or two. I'm part of a long-haul COVID study that OHSU has conducted since early 2021. My condition has been stable since February of 2021. It could be due to electrical instability in my occipital cerebral cortex or any number of misfires or fleeting misinterpretations of signals between various neurons in areas of my body. During the period of time that I'm on the ground, or wherever it is that I collapse, my mind retains an idea of where I have fallen and what is around me during the last moments of full sensory intake. My own Depending on the stability of the environment of which I'm in and my own mental and physical states at the time, the scene I open my eyes to has often shifted from the internal picture I was holding on to. I found that this is largely determined by how familiar I am with my surroundings, how comfortable I am within it, and where my focus was pre-blackout. These are things we contend with throughout every day, regardless of whether or not we have visual impairment. Our minds develop our reality piece by piece and lobe by lobe. Thank you very much.